Hello everyone, welcome back to our YouTube channel. Today, I will show you how to configure a REST API Modular Input App using API Key Authentication. As you can see on the screen, here is the process of how a client and server communicate with each other using an API key. For this tutorial, we will be using the OpenWeatherMap API, which acts as the API server. Then, we will use the Splunk REST API Modular Input App, which will act as the client to collect data from it. The OpenWeatherMap API offers a free subscription, and later in the tutorial, I'll show you how to obtain an API key. By following these first steps on the screen, using this API Key Authentication will successfully integrate the OpenWeatherMap API into Splunk. Here, I'm using the Splunk Sandbox that I have installed for my other YouTube tutorial. I'll provide all the necessary links for you to follow through. Let's log into our Splunk instance using admin credentials. I have installed the Splunk REST API Modular Input App. I will also provide links on how to install this app in the description below. Let's open the app and check the data inputs. On the Quick Start page, click on Data Inputs. Here is the REST configuration page where we can create inputs. To integrate data from the API, click New to see the requirements. Before we fill out these settings, let's go ahead and obtain the API key. Visit the website of OpenWeatherMap. On the top menu, click on API. Scroll down to locate current weather data. This is the data we will be using in our tutorial. Now, click on the subscribe button to view the different subscription options for this data. For our tutorial, we will only be utilizing the free version. The first step is to request an API key. Click on Get API Key. This will redirect you to another page to create an account. Since I have already created my account, proceed to fill in the necessary information for your account. Follow along with me on the screen. Once you have completed the account creation, OpenWeather will send you an email to verify your email address. Simply click on the Verify Your Email to link the email account. After verifying your email, you will receive another email containing API instructions. This email will include the API key and other essential details. Following the instructions in the email, please note that your API key will be activated within the next couple of hours. To verify that your API key is working, click on the link provided under Example of API Call. Since my API key is already activated, clicking the link should display JSON data results. Now that our API key is confirmed to be working, we have successfully completed the second step in requesting and activating our API key. Now, let's return to the OpenWeather website and review the API documentation. It's crucial to go through the API docs to understand how and what data we can pull. Here, we can explore various parameters that need to be followed, including details on how to make an API call and more. Now that we've covered the documentation, let me introduce another helpful application that we can use to test and interact with our API. I'm going to open Postman. Now, follow me on the screen as I demonstrate how we can test our API using Postman. I'm going to copy the link provided in our previous email and demonstrate how to test it here in Postman. Once pasted the URL link here in Postman, we can see different parameters we can modify if we want to get specific data. By clicking the Send button, it will display the response to our request. The data should match what we see in the browser, right here in Postman. Now, let's return to the Weather API and check the weather for Toronto since I'm based here. I'll be using this data for our tutorial. As you can see, this is the current weather in Toronto today. Now, let's use Postman to obtain the same data. Change the value of the query params to Toronto, CA. As you can see below, the temperature result is different from the website. We need to update the unit of temperature to Celsius. To update the temperature unit, let's return to the API docs to verify which parameters should be adjusted. Now, let's test the unit parameter in Postman. After updating the necessary parameter and value, the results should match. As you can see, the temperature results almost match in Postman and on the OpenWeather website. The difference is that the results on the website are rounded off. After successfully testing our API data here in Postman, let's also test it on our client server, which is our Splunk server. To do this, we can convert our tested URL here in Postman into a curl command. To convert it into a curl command, click on this icon located on the left side of the screen. Here, you'll find a variety of options serving different purposes. For this tutorial, our focus is on the curl command for Linux to test the functionality of our API. Copy the curl command. SSH into the Splunk server, then execute the curl command. The results should be similar to Postman, displaying JSON data. Now that our API is also working on our client server, we can use this API URL in our data inputs. Before we proceed with step 3, let's create our index where we'll store our API data. Go to Settings and click Indexes. I'll set the index name to weather_API. This index name is required later in our data inputs configuration, but feel free to use the default index if you prefer. It's considered a best practice to create a separate index for each integration or new set of data. Let's return to the Data Inputs page. Now, let's initiate step 3, sending a request using the API key. Fill in the necessary information to complete our request. In the REST API input name, I'll put OpenWeather_API. For the activation key, this app requires a license. But don't worry, it has a free trial version. Follow along with me on the screen to request the activation key. Simply fill in the details, and once completed, they will send you the activation key to your email. Don't forget to click the Get Free 14-day trial key button. After that, copy the key from the email and paste it in our data inputs configuration. Next, copy the URL from Postman for this endpoint URL requirement. For the authentication type, choose Basic since there is no dedicated API Key Authentication option. We can skip the other settings here, such as SSL certificates, proxy settings, etc., in a production environment. Some of these settings are important to secure the integration. The next crucial setting we need to fill up here is the polling interval. This determines how frequently our inputs will call or pull data from the endpoint API. For this tutorial, I'll set it to 3 minutes and seconds. I'll set the source type name to be the same as the data input name, which is weather_API. Now, click on More Settings for us to configure the host and index. I'll leave the host as default and set the index name that we created earlier. Click Next to save the configuration. Now that we have successfully sent a request using the API key, the API server should send the specific data we set in our configuration. Let's go ahead and search for the data in our index. To verify the response from the API server, we are expecting the current weather data for Toronto in JSON format. Now that we have successfully integrated the OpenWeather API, using the API Key Authentication, let's proceed to create a simple dashboard based on this data. Let's go ahead and make our data usable. By creating a simple dashboard, we'll replicate some of the representations of the current weather on the OpenWeather website, including details like current weather, feels like, etc. First, let's use the main temp field name to get the latest temperature. We can achieve this by using the stats command in the latest function. Next, let's round off the numerical value result to make it consistent with the OpenWeather website. Now, let's save this data as a new dashboard. Let's also change the visualization to make it more meaningful and easier to interpret. Follow along with me on the screen as I update the other configuration settings for this dashboard. I'll provide the XML code in the documentation for your reference. Since the main temp and fills have the same results, let's just replicate the XML code for the first panel we created and update the field in the query. Now, let's create the last panel for displaying the current temperature and fills over time by using the time chart command. Now that we've successfully integrated the OpenWeather API into our Splunk environment, created a data input, and built a meaningful dashboard, you've learned how to leverage external API. Remember, this tutorial covered the basics, and there is so much more you can explore and customize based on your specific needs. I hope this tutorial was helpful for you. If you have any questions or if there's a specific topic you'd like me to cover in the future, please let me know in the comments below. Don't forget to like this video if you found it useful, and subscribe to our channel for more tutorials and tech content.